Okay, IBAISL2. Today we are talking about sinusoidal curves and transforming them. The first thing we're going to start with is what the parent curves of the sine and cosine look like. So the sine curve starts at 0. So at 0 degrees, it's at 0. Then it goes up the mountain at 90 degrees, then back down to what I call home base, but there's another word for home base. Then it dips into a valley here at 270 and then back up at 360. Now this curve continues, like you can go past 360 degrees, but it's just going to go through the same process again. Like it'll go up the mountain, back down into the valley. And same thing if you were to back it up into the negatives, it would continue this way as well. This home base, the line through the middle, this line right here, this is called the principal axis. A lot of times I call it home base, but the book calls it principal axis. A cosine curve is almost the exact curve, it just starts in a different place. So rather than starting at the principal axis, cosine starts at the top of the mountain. But then it behaves the same way, like it goes down the mountain in the first 90 degrees, then it dips into the valley with the next 90 degrees, then back up to home base at 270, and then all the way back up the mountain at 360 degrees. So this would continue on either side, but that's what the general cosine looks like. As I said in the first part of this video, the principal axis is the line halfway between the maximum and the minimum. So from the bottom to the top, it's the halfway point. The way you find that, if you're just given numbers about the minimum and maximum, like the lowest and highest point, is that you can average the minimum and the maximum, add the min and max together and divide by 2. That's going to tell you the principal axis. We're also going to talk about the amplitude of curves. That's the distance from the principal axis to the max or the min. So on my diagram here, if I were to take a max up here at the top and a min down here at the bottom, the principal axis is going to be directly in between those two. So it's going to be halfway in between the top and bottom. So that's your principal axis. The amplitude is the distance from the principal axis to the top or the distance from the principal axis to the bottom. It's the same distance no matter what. So this is amplitude. Both of those are amplitudes. Amplitude is never negative, it's just a positive number. Now the period is the horizontal distance until the curve starts to repeat. We're going to have a formula for this eventually, but visually, it's like, if you were to start here at the principal axis and then go through, up the mountain, down into the valley, back up, at this spot right here, you would start to repeat that process of going up the mountain, down into the valley. So when it starts to repeat, that period is the horizontal distance. So here we'll use yet another color. This horizontal distance is the period. Okay. For the parent curves of sine, cosine, we're going to label all these things of the range, the domain, the period, the principal axis, and the amplitude. The range is just the top to the bottom. So here, this is the top is at 1 and the bottom is at -1. So we'll just say that this is, the y values are between -1 and +1. The domain goes forever to the left and forever to the right. So this is just x is an element of real numbers. It's all numbers, negative and positive. The period of this curve is 360 degrees. That's because if you were to trace the curve here at 0 We go up the mountain, down the mountain, into the valley, back up. But then right here at 360 is where it would start to repeat, like go up the mountain again. So the period is 360. The principal axis is directly in between the top and the bottom. So with this case, it is the y or the x-axis, which is y is equal to 0. And the amplitude is that distance from the top to the bottom, or top to the principal axis, or bottom to the principal axis. So the amplitude is just 1. Now the cosine curve is very similar, that it's the top is at 1 and then the bottom is at -1. So that one still goes from +1 to -1. The domain is all real numbers. The period is also 360 on this one. You can see that because if you start here at the top of the mountain and then go down, back to home base, into the valley, home base, up the mountain again, you would start to repeat the process here at 360 degrees. So the principal, or the period, is 360 degrees. The principal axis on this one is also just the x-axis. Now we are going to have examples where it's not just the x-axis after it's undergone some sort of transformation. The cosine curve also has an amplitude of 1. Okay, most of these transformations I think are going to be done from a calculator perspective, but I am going to walk you guys through how to sort of graph this right here, 3 sine 2x minus 2. So the first part here, this 3, this is your amplitude. You can think of it as a vertical stretch of the graph, but really, like if you start with an amplitude of 1 and then you stretch it by a factor of 3, your amplitude is 3. This guy on the back is going to be your vertical shift. But vertical shifts in terms of sinusoids affect the principal axis. So in a way, the principal axis is just going to be -2. This guy controls the period. And the way it controls that is that it's, period is equal to 360 degrees divided by whatever that number is. We'll call it B right now. Another way to think of this number right here is it's how many parent curves fit into 360. So if that number is 2, that means 2 full curves fit between 0 and 360. Therefore, one of them would just be from 0 to 180 degrees, which makes sense with this equation. Excuse me. Where if you take 360 and divide it by that number, it tells you by what the period is. So let's see. Principal axis is going to be at -2. Because of this right here. Then it's going to go up 3 and down 3 from that spot. So up 3 from -2 means that it'll go all the way up to +1, and all the way down 3 from -2 is -5. So I know my whole curve is going to live in between those two things. There's my max and min. The amplitude, well, we already did amplitude. So a sine curve starts at home base. It starts right here. And then it goes up through its mountain and then back down and then into the valley and then back up. Because this value is 2, that means that the whole curve is going to happen between 0 and 180. So in between 0 and 180 means halfway through it, it will be 90, and then quarters will be 45 degrees. So at 45 degrees, it's going to go up the mountain, then back down, And then at 135 degrees, it's going to go into the valley and then back up. So it would continue on in this fashion. And it would go we would go in the negative direction as well, that there would be a valley here at negative 45 degrees, back up to the principal axis at negative 90, up to the top at negative 135. So that's what the curve would look like. You don't need to use these training wheels, as I put them, these dashed lines. They're technically not part of the curve, but I think it's okay to use them right now just to draw a really pretty curve. Example 2. The graph of a function of the form negative 20 cosine 3x is shown on Clara's GDC. That's graphics display calculator. Write down the amplitude of the function and justify your answer. Well, the amplitude is this number right here. Well, it's not the actual number. Amplitudes can't be negative. So the amplitude is 20. Now, does this make sense in terms of the picture? Like if you look at the graph here, does this distance look like 20? Yes, it does look like 20 because if this is 10, this is 20 right here. So that's a distance of 20 right here. Write down the period of the function and justify your answer. I don't know how you want me to justify the answer, but I'll show you how to find the period. The period has to do with this number right here, the 3. Now, the period is not 3. That's the first mistake I'll see. The period is how often the curve repeats. So if I start to trace the curve, starting here, and I go up to the principal axis, and then up the mountain, and then back down to the principal axis, and then into the valley, right at this point right here, if I start to go up out of the valley again, I already did that over here. So that means that this distance right here is the period. So if halfway is 60, the full way would be 120. So period is equal to 120. Now, back up here, I showed you guys how to find the period using 360 divided by b. So let's try that. Period is equal to 360 divided by 3, which is indeed 120 degrees. So that makes sense. Last example. Simon explores tidal patterns by measuring the depth of the water at the end of a pier. He finds that the data can be modeled with this function. So here's our function, where x is the number of hours after midnight. Simon's laptop crashes, but he finds a paper with some of his data. Determine the values of A, B, and D in Simon's model. Okay, we know that A is the amplitude. So if you were to cut a principal axis right through the middle, the amplitude is going to be this distance right here. The lowest this graph gets is 5, and the tallest it gets is 11.2. So if you add 5 and 11.2 together, you get what, 16.2? But that's the distance from the bottom all the way to the top, which is double the amplitude. So you actually need to divide that in half. So 5 plus 11.2 is 16.2, and divide by 2 is 8.1. So because this entire distance is 16.2, half of it is going to be 8.1. So for part A is equal to 8.1 feet. No, what is this, meters? Does it say? Wow, what a bad problem. They really don't say what units this is in. I assume it's probably meters. Now, we just found the A value right here. That's the amplitude. The D value is the principal axis. So the principal axis is halfway in between 11.2 and 5. So we can just average those two together to find the principal axis. So D is going to be equal to 11.2 plus 5 divided by 2. Oh no, did I screw up? I think I did screw up. Classic. Hold on. 11.2 minus 5, 6.2. Okay, we got to back up, you guys. I messed up the first part of it. My apologies. So, if I go back over here to find the amplitude, the distance from 5 to 11.2, I was adding those two numbers together, and I shouldn't have been. The distance from 5 all the way up to 11.2 is 6.2. So that's this vertical distance. That's 11.2 minus 5, which is 6.2. But then the amplitude is just half of that. So the amplitude is going to be 3.1. Then the principal axis is that part D right there, the letter D, and it's going to be halfway in between 5 and 11.2. So we can add 5 and 11.2 together and divide by 2. That's where we get the 8.1. So 5 plus 11.2, divvy that by 2, and you get 8.1. Which makes sense because that means this spot right here on the y-axis is 8.1. The last part is that B value, and the B value you get from the equation 360 divided by B is equal to the period. To figure out what the period of this curve is, like it's this distance from here all the way over to here. In this first chunk, we go 3, so this is 3. Then the next chunk goes all the way up to 6. So like, yeah, this right here is 3. This is 6. Then it hits 9 right here. And then it starts to repeat at 12. So the period is 12. But that's not the B value. The B value is 360 divided by B is equal to the period, which is 12. To solve this, you multiply both sides by B and get 360 is equal to 12B. Divide 360 by 12 and we get 30. That means the equation is y equals 3.1 sine of 30x plus 8.1. The interpretations of what's happening with these waves, that means that each, or these tides, the tides go up and down 3.1 meters. So 3.1 meter tides up and down. This number, 8.1, is your average tide. Then interpreting that 30, what that means is that within 360, that the curve is going to repeat 30 times. So really what this means is that the function repeats 30 times in a domain of 360 hours. All right, you guys, that's all I have for you today. Happy studying.